This is numbers 13 through 18 on the study guide for Unit 1. So on number 13, I see a radical around both the numerator and the denominator. So what you're going to need to do is you're actually going to need to separate this so that you have the square root of 20 over the square root of 3. And since we know we can't have a radical in the denominator, you're going to want to multiply it by something that's equivalent to 1. Or in other words, get rid of what's in the denominator here by multiplying that denominator over itself, because this would equal 1. So then on the top here, I would get the square root of 60 divided by, on the bottom, 3 times 3 would be 9, so the square root of 9, which is 3. And then all I need to do on the top is I need to simplify that radical. So if you take the number 60, you can say that that's equal to 3 times 20, that's prime, and then 20 would be 10 times 2, and then 10 would be 2 and 5. So I see I have a set of 2's that would comprise the 60. So inside we have 2 times 2 times 3 times 5, all of that over 3. This 2 can come out, so what that leaves us with is 2 on the outside, square root of 15, because we would actually multiply 3 and 5 back together again, and then all of that would be over 3. So you cover up the radical here, and you say, does 2/3 simplify anymore? And it doesn't, so that would be your final answer. On number 14 here, I have 12 square root of 15 over 8 square root of 5. And what I want to point out is that if you covered this up here on this side, you should be able to see that square root of 15 divided by square root of 5. Since they're both inside a radical, you could actually do 15 divided by 5, which is 3, square root of 3. But y'all, I know some of y'all are prefer to stick to the same routine, so you'd say, okay, the thing I have to get rid of is the square root of 5 in the denominator, and this is fine too if you prefer to do this. So from here we have 12 square root of 15 breaks down into 3 times 5, and then we have this 5 here that carries over, so this would be 15 times 5, just like you see here. Over the bottom here we would have 8 times square root of 5 times square root of 5 is square root of 25, which is 5. Then I see I have a set of twins right here. I can pull it out. So 5 times 12 is 60. And then I still have that square root of 3 left here. All of that over, this would give me 40. So then notice we would cover up that square root of 3, and we would say we need to simplify the fraction here, 60 over 40. So what goes into both of them? 20 can go into both of them. 20 goes into 60 3 times. 20 goes into 40 2 times. So that leaves me with 3 square root of 3 over just 2. And then that would be my final answer. Alright, on number 15, it says that we are to find the perimeter of the deck shown. And so what we're going to do is we're going to add all the way around. So that means that if we're doing perimeter, we add this side plus this side plus this side plus this side. When you do that, you want to add your x's, because those would be the same. So x plus 2x is 3x, plus 1 more x is 4x. And then now we add all our numbers, because those are like terms. 3 plus 4 is 7, plus 3 is 10, plus 10 is 20. So this would be the perimeter. Then this one here says find the area. Well, remember that the area for a rectangle would be length times width. Some of y'all say base times height. It's kind of the same thing. So you're going to do your length times your width here. And because it's a binomial times a binomial, remember we want a FOIL. So x times 4x would be 4x squared. So that's the first term. Then we got the outside terms. X times 2 would be 2x. Then we got the inside terms. 2 times 4x would be 8x. And then 2 times 2, which would be 4. And so then we clean this up and look for our like terms. So I have 4x squared. This would give me plus 10x. And then I still have plus 4. So that would be my final answer. On number 17, we're still finding the area. And remember, the area for a triangle is 1/2 times the base, so in this case 2x plus 6, times the height, so in this case x plus 3. Now when I see this, I'm going to go ahead and distribute this 1/2 to this first binomial, because both of those are even, so they're divisible by 2. So area is equal to 1/2 of 2x is just x, and 1/2 of 6 would be 3. So now I have x plus 3 times x plus 3, so we FOIL. First terms would give me x times x, which is x squared. Outside terms would give me x times 3, which would be 3x. Inside terms would give me 3 times x, which would be 3x. And outside terms here, or the last terms here, would give me 3 times 3, which is 9. And so we just clean this up, and we have x squared plus 6x, those two are like terms, plus 9, and that would be my final answer. Number 18 has a little bit more work involved in it because it says find the area of the unshaded region. So that means that we're finding the area of this, because if you look carefully on your study guide, this is the part that should be shaded. So to do that, what we need to do is remove this one shaded region. Removing means we're subtracting it off. So the first thing we want to do is find the area of this large region. So that would be your length times your width. So if we did that, that would be 2x times x, which would be 2x squared. And then we have 2x times 3, which would be 6x. So this would be for the large square. Then we want to do the same thing here to the smaller rectangle here. I think I said square before, it's a rectangle. So smaller rectangle here. We want to find the smaller one. So I'm going to draw a line here. And we're still going to do our length and our width multiplied together. So x times x would be x squared. X times 2 would be 2x. So what we've got is this big one here, which would be 2x squared plus 6x. And we want to subtract, in our parentheses here, this whole piece here. So that means x squared plus 2x we're subtracting off. Notice that we're subtracting it, and that means we have to subtract it from each part, which means we have to use that distributive property. So 2x squared minus x squared would be x squared. 6x minus this positive 2x would be 4x, and that would be our answer.